This is a review of Exam 3, Question 1. That's a multiple choice conceptual question, and you must show work for partial credit. In Part A, upon what basic quantity does kinetic energy depend? Well, we know that kinetic energy is equal to 1/2 the mass times the velocity squared. So the choice is speed. Part B, a 0.500 kilogram ball moves in a vertical circle at the end of a 1.50 meter long string. When the ball is at the bottom of the circle, which is the correct expression for the tension in the string? So let's draw a little picture. Here's the ball. It's at the bottom of this vertical circle that it's undergoing. And if we do a free body diagram, we have the tension acting up and the weight acting down. And the tension must be greater than the weight because it causes the velocity vector to change its direction. So if we sum the forces in the y direction, we have the tension minus mg is the net force, which is equal to the mass times the acceleration, which is v squared over r. So the tension is equal to mg plus mv squared over r. So the correct answer is choice 2. In the next problem, we have a bullet B, and it's fired with the same speed as bullet A. Bullet A has half the mass as bullet B. If bullet A has kinetic energy K sub A, what then is the kinetic energy of bullet B, K sub B? Well, if we take the ratio of K sub B to K sub A, we have 1/2 K, 1/2, excuse me here, I'm making a mistake. We have 1/2 m sub B v squared over 1/2 m sub A v squared. Which I could rewrite as 1/2 mb v squared over 1/2 times m sub B over 2 v squared. Since the mass of bullet A is half that of bullet B, so this is equal to 2, which means that K sub B is equal to 2 times K sub A. In part D of question 1, an object can be slid down one of the 3 different ramps, as shown to the right. The object starts from rest and the final elevation loss of each of the ramps is the same. Well, we know that the work done by the gravitational force is equal to the gravitational force times the vertical displacement. So we know in part 1 where there is no friction, that the only force acting on the object is the gravitational force. And so the work done in this case, in each case, is equal to mgh. And even though in the third part here, where there's a displacement down h, and then h1, say, and then there's a vertical upward displacement of delta y, then that work going upwards is negated by the work going back down. So the total work is equal to mg times h1 plus h2, which is the same in each case. So the work the work done in each case is the same, which means that the kinetic energy is the same for each case. In the second part, the work done by the gravity, once again, gravitational force, is once again going to be the same in each case. But now it says that the friction is the same no matter, there's a frictional force experienced by the object no matter where on the ramp the object is in each ramp. Well, if you examine the total length that the object must travel, you see that the length, the travel of travel in x is less than that of y, which is less than that in z. And we know that the work done by the friction is equal to minus f sub k times d. So, since the work done by the friction in in ramp x will be less than the work done by the friction in part y, ramp y, which is less than the work done by the friction in ramp z, then the kinetic energy in x must be greater than the kinetic energy in y, which is then greater than the kinetic energy in z. And that concludes this video.